All right, looks like we're live. Hello everyone and welcome to yet another zoozing session. How about that? But you didn't expect that shit to happen today. Let's make a little bit of an announcement, forcing a CD. Just super quick. And the thing we're doing today is rather peculiar, even though I don't know the meaning of word peculiar. So I'm just using it out of nowhere for no reason. So let me see. So what we're gonna be doing today. Right circle, live on Twitch, right? So that's where we are. We are on Twitch still, for whatever fucking reason, even though this platform is horrible, right? It is leaking my personal data, but we're still live on Twitch, right? I don't know why, still don't understand why. https twitch.tv/zooding, and we're gonna ping everyone who's interested to be pinged, and there we go. The stream has officially been started. Hello everyone who joined us today. Hello Bitstream, hello Man Woppery, Pastito, I hope I pronounced your nickname correctly. And Toby, hello, welcome. So, what are we doing today? According to the title, we are making a white noise generator. That's what we're doing today. The question is why we're doing a white noise generator. Hello everyone who just joined. So recently I started to do very, I would say, deep coding sessions when I would actually completely turn off the internet. Right, I would actually code for several hours without any internet at all. And the question is, how do I do that without Google or without Stack Overflow or anything like that, right? Essentially, I kind of plan those sessions, right? So for instance, I need to develop something in Go using a particular Go library. Like, I know that I need to do that. So that means I can download the documentation of Go, like a language reference, the standard library reference and stuff like that. With Go doc, you don't really have to do that. Also, I would download the documentation for the library I'm going to be using, and also the source code of the library. So I can go into the source code if the documentation doesn't cover something that I'm interested in. And without any internet, I would be forced to actually read documentation and look into the source code. And I find it like that kind of does not interrupt my workflow, because I'm integrating reading the documentation and exploring the source code into the workflow of development. Anyway, so I also, along with the documentation, I download a lot of music, right? So I can put it in the background and stuff like that. But what I found is that a lot of music that I download, even though it's kind of good for background and stuff like that, a lot of music is just distracting. So the only thing I found that is not distracting is a white noise, right? So, and there's a lot of white noises on YouTube. So you can just go to YouTube, and one of the most, most suitable for the background white noise is probably the one that comes first when you Google white noise. It's this one, right? But here's the problem. This white noise is like 10 hours long. So I can't just download it with YouTube DL, right? Because the size is probably enormous, right? And it will take ages to download. So what I'm thinking is that, like, I can just write my own white noise generator, right? So in that way, I can just have white noise without downloading anything and without taking too much space on a hard drive and stuff like that. So yeah, and that's what we're going to be doing today. Today we're going to just write a simple white noise generator. I know nothing about random numbers and how to generate noises of different colors. There's not only white noise, there's also like a pink noise, and there's also brown noise and stuff like that. And there are just, the differences between them is that how amplified certain frequencies are in those particular noises. So I know nothing about that, but I do know something about the sound, right? So because I have unfinished like musical education and whatnot. So, and I'm gonna try to apply the knowledge that I have about the sound to make a white noise generator and just explore the idea without reading any articles on how to generate white noise properly. I'm gonna do that first, and if I get stuck, maybe then I'm gonna read some articles that explain how you generate a good white noise properly. So that's gonna be the plan for today. That's going to be the plan for today. So that's what I want you to do. So we sort of are taking a break from developing Porth, right? Porth is finally self-hosted, so I allow myself to take a break and develop something else, because it's kind of difficult for me to develop the same thing for a long period of time. I like to switch up my projects to not get bored and stuff like that. Deep Singularity, hello, hello, I good Duke, hello, hello, welcome, welcome everyone who just joined. Really glad to see you all today. So I don't know, maybe I'm gonna actually put this thing in the references, right? So this is gonna be the white noise, black screen, sleep study, focus 10 hours. Okay, I'm gonna copy paste this entire title just to reference this entire video. This white noise is actually quite good. I really recommend this one. So it's not like a particularly white, I think, because it doesn't sound like white noise, right? If I just generate a white noise, it's not going to sound like that. So they amplify it and reduce some particular frequency. So it's kind of interesting. So it's not like proper white noise, I think. I think there were some tricks in there. So we've got some donation, I think. Is it donation? I think it was a donation, so maybe it's a question. Just a second. I need to load up my my Streamlabs. So Matty7267 donated $1 saying, hello Tsoding, how are you? I'm fine, actually. I'm feeling really great. So I moved back to my old apartment, so everything is Gucci. Everything is Tamaguchi. Thank you, thank you, thank you. So, all right. So let's go ahead and try to implement that. So how are we gonna call our white noise generator? How are we gonna call it? I don't know. So let me think. White noise generator. So maybe wine. I think it's a good name for a white noise generator, right? Wine. So we're gonna go with wine. So wine. I'm gonna create a readme. Wine, not white, wine. White noise generator in C, right? Okay, and the license we're going to use is the same license I use everywhere. License, is that how we spell license? I think this is how we spell license, so this is going to be MIT license. And we're going to be using SDL for that, right? So because I want to make this thing more or less cross-platform, right? And SDL has capabilities to work with sound systems, right? So let's go ahead and use SDL. So I'm going to create like a very simple boilerplate project. So this is going to be, let's actually start with like hello world project, right? So this is going to be hello world. Toby Prime subscribed with 2 months. Habab. I don't know what that means, but thank you so much for 2 months of Twitch Prime subscription. Thank you, thank you, thank you. And welcome to our epic white noise club. That's right. So what we're doing here, we're generating white noises. All right. So hello, everyone. Broken Kernel is gifting 1-tier subs to Tsoding community. Thank you so much for gifting 1-tier subs. And Nice La, welcome to our epic C club. That's right. We're programming in C in here. So let's write hello world. Right, so this is going to be the first thing that we're going to write in here, and I don't know, so do I need to create like a make file, or am I going to go with a build shell script? I think I'm going to go with a build shell script to annoy C++ people even further. Because C++ people believe that you're supposed to be using CMake or some other super complicated build system, but in reality you don't have to use them. And every time I show that you don't have to use them, that annoys the hell out of them. So that's why I'm going to be using just a regular shell script file. Right, so I don't know, maybe it's going to be like a bin sh. Right, and the very thing that annoys them the most is the fact that it just works, right? So they cannot prove me that you have to use CMake to build the project. They cannot just prove me that because I can just show them the shell script and it works, right? So just like it works. You don't have to use CMake. Okay, so we got another Twitch Prime, Macrons. Thank you so much for Twitch Prime subscription and welcome to our epic shell script club. That's right. Welcome, welcome, welcome. So let's continue. So we're gonna just build this thing with CC. It's gonna be wine. The input is gonna be main C, and I suppose we're gonna create like separate environment variables for C flags and for the libraries. Right. So the C flags is gonna be equal to wall. We're gonna enable all of the warnings. We're gonna turn all of the warnings into errors, and we're going to use the C11 standard, and we're gonna be very pedantic about it. Pedantic. And I'm also gonna enable all of the debugging information just in case we want to debug this thing. So in terms of libraries, we're not going to use any libraries for now, right? Because we're writing a hello world. And I'm also going to enable X and E. X is going to trace everything that is executed in the shell, and E will fail on the first error in the shell script. Right, so I'm going to do something like this, and I'm going to try to run this entire thing. And pedantic, right? What? And recognize command pedantic. So that's... Oh, okay, I see. Pedantic. There we go. So we're being very pedantic about it. And if I try to run wine, it says hello world. There we go. So let's actually try to write a very simple like SDL example. Like let's try to initialize SDL. But as far as I know, we don't really need the whole SDL. We only need the audio subsystem, right? So first of all, let's include SDL. And we won't be able to build this entire thing, right? We won't be able to build this entire thing because we don't have all of the necessary flags set up. So what we need to do in here is package config c flags SDL2. So this is for the flags. And for the libraries, we're going to be using package config libs SDL2. There we go. So maybe on top of that, we want to have something like M, library M for the math, and so on and so forth. And there we go. All right, so that seems to be working. So let's go in here and initialize the audio subsystem. So how do you do that? I don't quite remember. Let me open this thing and find SDL init. Right, so there should be a function SDL init. Yes, there we go. So we're going to be initializing the SDL, and in here we have different subsystems that we can initialize. So one of them is the audio, right? We don't need timer, we don't need video, joystick, or anything like that. Maybe we're going to have video in the future, right? So because I want to have some sort of like a simple interface where you can control different parameters of the white noise. So we can just develop a simple immediate GUI for this kind of thing, but not for now. For now, we're going to only initialize the audio, right? So we are initializing the audio. And as far as I know, SDL init exits with negative value on an error, doesn't it? Initialize the subsystem specified by flags, but they say nothing about what's the result in here. But usually the convention is if the result is negative or like -1, that means an error. And in that particular case, we're going to just print an error. So error could not initialize SDL because of this specific reason, right? And you can get the reason from SDL get error, as far as you know, right? That's where you can get it from. So after you're done with SDL, you can just quit, and that should be it. There we go. So we couldn't actually compile it because I forgot semicolon. Right, so somewhere here we can just print something like OK, right? Just to indicate that everything was okay, and everything in fact was okay. So I don't remember what you have to do after that, right? So I think you're supposed to open the audio device of some sort. Let me actually see. So SDL, this is audio. I think it's open Audio, yeah, that's right. So open audio. So let's take a look at this function. So this function is rather interesting. So you have audio spec. You have something called audio spec. And this is a structure with a lot of audio parameters, right? So here are all of the audio parameters. And you specify what you want from the audio system, what kind of parameters you want. And then you can specify the pointer to what was actually obtained, because not always you're going to have the system where these parameters are available. So the SDL will try to find the closest audio device with the closest parameters. So you have to specify desired ones. But then if you get obtained and there will be some differences, you'll have to handle them. As far as I know, I actually learned that recently. You can specify obtained as null, and it will try to always return the device with the desired parameters. And if there is any conversion that is needed to be performed to turn desired or to turn obtained into designed, it will be done automatically by SDL. So this kind of conversions can be done by SDL, but I would presume that it will be a little bit slower, because like some conversion is going to be slower than no conversion, probably. Right? So we can actually read that in the documentation. Right. So let me see. So is there any information about obtained? Right. If obtained is null, the audio data passed to the callback function will be guaranteed to be in the requested format and will be automatically converted to the hardware audio format if necessary. This function returns -1 if failed, and so on and so forth. So I think we don't really need too much of the speed, I suppose. So because it's just like a white noise. Even if we slow down a little bit, is anyone gonna notice? And on top of that, we're not doing anything like super intensive. So I think we're gonna just say, give us that precisely format, and we're not gonna care about what's obtained, and we're gonna let the SDL to convert everything. I think it's actually a pretty good idea. Okay, so let's actually see what needs to be specified in the audio spec, right? So let me find the definition. So frequency is basically samples per second. Okay, so I'm gonna actually do the following thing. SDL audio spec, and it's gonna be desired. Let's start with the frequency. So we're gonna use 48 thousandths, right? 48,000 samples per second, because it's like some sort of like a standard one, right? So, and then what kind of format are we going to be using? This is very interesting. So it's a separate type format. So I think this format is defined as a mask of some sort. Right, there we go. It's actually pretty complicated mask. It's not that complicated, but I think there are predefined masks in here, right? So audio format flag. So there we go. Yeah, I think you can just grab one of those and be fine with that. So I think we're going to be using like a 16-bit format, probably sine, LSB or MSB. I think we're going to use the least significant byte because it's the most logical one, right? So I think audio as 16 LSB is a good one, right? 16 has a way bigger resolution than 8 bits, and we don't really need 32 bit resolution, right? It's too much for white noise in my opinion. And least significant byte is the basically ordering of x86-64, so I think it should be fine, right? And we do want to have like a negative one because it will simplify using something like sine if we want to use sine or something like that. So, all right. Let me see. So I'm gonna specify this thing, and let me find this stuff in here. So how many channels are we gonna have? I think we're gonna have just like one channel, right? But there's no need to like have two of them. It's just a white noise. So channel is gonna be 1. All right. So the next thing, silence. The audio buffer silence value calculated. I think I don't have to specify anything in here. So audio buffer size in sample frames. Total samples divided by channel counts. In sample frames, total samples divided by channel count. I'm not sure if I'm gonna use that. Audio buffer size calculated. So as far as I can remember, there are two styles of API in here. There is like an API that allows you to queue the audio that needs to be played, and there is also API where you provide the callback, right? Essentially, instead of like pushing the audio, the system will request the next sort of like frame of audio, right? So, and in our case, I think it would be easier to use the callback style because I don't want to think about like specific buffers and calculating buffers and stuff like that. I want this system to just request the next chunk of data and I want to just give it to it. So that way I don't have to manage the buffer myself, if that makes any sense. So in that case, I don't think like these kind of parameters are important. The only thing we need to provide is the callback, right? Hopefully. We'll see about that. So let's take a look at the callback. Right, so what is SDL callback? So it accepts the user data, it accepts the pointer to the beginning of the stream and the length of that stream. And essentially, once SDL calls this callback, we have to fill up that buffer with data. In our case, the random data, because we're generating white noise. Right, so let me actually take a look at that, put it in here. So, and let's call it white noise, right? So it's going to be white noise. We have a user data, we have a stream, and so on and so forth. So in here, we're going to ignore user data, I think, and I'm going to just mark this thing as not implemented. We're going to just mark this thing as not implemented. Okay, so white noise. To do white noise is not implemented. Right, so do we need to have anything else in here? So call back, and we're not going to have any user data for now, so I think the only thing I'm going to do in here is just set the callback. Right, callback equal to white noise. There we go. So let me, did I remove it? Yeah, I accidentally removed it. So I'm going to give the pointer to that one. Obtained is going to become null. All right, and then if this thing is less than 0, we're going to say that we couldn't get the device. We couldn't get the device. So fprintf std error, error could not open audio device. Right, and then we're going to specify what exactly happened. Get error. Get error, and we're going to exit with 1 in case of that specific error. I suppose we'll have to maintain the event loop, right? Because the SDL system will request the data to play or something. We'll see how it will go. Right, so assert is not available, so we'll have to do something like assert.h. And there we go, so it said okay, and then it exited, right? So we had no opportunity to actually play anything in here. So I suppose we'll have to maintain an event loop. So to maintain an event loop, we probably have to use the event system, right? So let's just go ahead and do that. Usually I like to have like a boolean that indicates that we're about to quit or something. And while it is not true, we're going to be pulling the events, right? So we're going to have event in here. And while, I don't remember what's that function, right? SDL event, SDL pull event, right? So that's what we have to do. So if not null, returns 1 when there are any pending events, and 0 when there is no events available. So essentially what that means we have to do while SDL pull event, we have to handle all of that, right? SDL, and if we take a look at the event type, right, and it's SDL quit, we're gonna say quit equal true, I suppose. And that's it. I'm not sure if that makes any sense, to be fair, in terms of the sound, because we don't have a UI. That makes sense for the UI. Anyway, so let's actually go ahead and try to run this entire thing and see if it's going to work. Okay, we don't have a boolean because in C, for boolean, you have to include a special thing, std boolean. All right. Oh, okay. So it is working right now, so it is doing its own thing, so I actually canceled it. So now we should be ready to fill up this thing, fill up this buffer. What's funny is that it's supposed to crash. This thing is supposed to crash, but it didn't. Because like I put like assert false in here, so that means it's not really doing anything. It probably blocked on events. So what we have to do instead, I think, is just to have this infinite loop, and maybe then it will crash. Is it crashing? It is not crashing. Why is it not crashing? I'm actually surprised. It's supposed to be crashing. Oh, I think I know what's going on. So this is something that you simply have to know when you work with SDL. Or you have to stumble upon it while reading documentation about SDL. You cannot just open the device. Opening the device is not enough. So the audio device starts out playing silence when it's opened and should be enabled for playing by calling SDL pause 0 when you're ready for your audio callback function to be called. Since the audio driver may modify the requested size of the audio buffer, you should allocate any local mixing buffers after you open the audio device. Okay, so basically they give us the time to prepare everything, right? So you open the device, then you have some time to allocate some stuff to prepare everything, and then you can say to SDL, okay, I'm ready, start calling my callback, and then it will start calling callback, which is actually pretty convenient. So, but it's easy to forget this kind of thing, right? That's what I'm saying. All right, so I suppose we don't really need to allocate anything. I'm gonna just start playing right away, and let's see what's gonna happen. And there we go. So it failed right away, saying that this thing is not implemented. Pretty straightforward, pretty easy. Okay. So let's go ahead and try to implement something. So what we're going to be doing in here, essentially, we have, how to say that? I really want to draw, but I don't know where I put my tablet, so just a second. Let me bring my tablet real quick, and I'm gonna quickly draw. Where is my tablet? Where is my tablet? I can't find my tablet. This is very, very annoying. Maybe my tablet is in my backpack. Okay, I can't find it right away, so we're gonna draw without any tablet. So we're gonna use our mouse then. We're gonna use our mouse. So, okay. So here is basically, I think this is time, right? This is time, and this is more of a value of the sound wave, right? And essentially we have signed 16-bit, right? So that means we have something like 2 to the power of 15 minus 1, I think. This one is minus 1 for the low value, and this one is another 2 to the power of 15. I don't remember specifically what are the ranges, or like, because of the sign, something you have to do minus 1 somewhere. I don't remember. So essentially what we can try to do is to generate random values within that range, right? Just generate random values for the samples within that range, and that will kind of produce something like, you know, white noise. Something like a white noise. I'm not sure if it's going to be a high quality white noise, but it's going to be some sort of a white noise. And we can use the random number generator that comes with the standard C library. All right. So let's go ahead and do this thing. stdlib. stdlib. So we don't have any user data, and for this one, it's going to be very interesting. So I know that a single sample takes 2 bytes because it's 16-bit, right? So that means I know for a fact that length is divisible by 2. Right, but just in case, I don't want to assume that, just in case I want to assert that. Right, I'm asserting that length is, oh my god, What the fuck is going on? What the hell is that shit? Something with a compose button. I don't quite understand what the fuck is going on. Excuse me? Okay. Some sort of compose button shit. I don't know. It never happened to me before. Okay, this one is that, and now I should be able quite easily to do the following thing. I can reassign this to sint16, right? Sint16, but now I have to come up with some sort of like name for these things. And I really don't want to do that. So you know what I want to do? I want to have a callback that looks like this. So this is going to be the white noise that accepts sint16 stream, right? And then also stream length, right? And in here, what I'm going to do, I'm going to just call this thing a callback, right? This is a callback, white noise, stream, length divided by 2. There we go. So basically this function just checks all of the types and converts all of the types, and this thing already accepts expected type according to the specified format. Right, and in here we can start like iterating through the samples, right? So this is going to be something like this, stream len plus I. And this is where we're going to start doing the following things. So we have to generate a random thing. We have to generate a random thing. So how can we do that? Essentially, so imagine that we have 16 bits, right? So 1, 2, and then we have 16 bits in here. So what we can say, we can basically take a value that looks like this, right? So it's 1 and then 15, 0, right? It's a 1 and 15, 0. And we can take this value, right, and use it as the boundary for rand, right? We're going to use it as a boundary for rand. That way it will generate the value between like 0 and 0, 1, 1, 1, 1, 1, 15, 15 ones, right? So, and that's precisely the value we will need. That's precisely the value we'll need. So, and then we can generate a, oh, this is not going to work like that because it's 2's complement. I was thinking is that I can just like, you know, then randomly generate 1 and it's going to be turn it into negative or not negative. This is not how it works because in 2's complement you have to like invert it and stuff like that, so it's not really going to work that well. But we can simply, I don't know, we can just use like condition and whatnot. I don't think it's that big of a deal. All right, so here we're going to have a rand and we're going to divide it by 1 and move it 15. So this is going to be 1 and 15 zeros, right? So this is the first value. Might as well actually do something like sint16. So this is the value. And the next thing I need to do, I need to have some sort of a sign, right? So I need to have some sort of a sign. So sint16 sign. How are we going to be generating the sign? So yeah, we can generate a value either 0 or 1, right? So 0 or 1. And then we can turn 0 into like -1 or and 1 into 1 or something like that. Or 1 into 1. So, but that means we'll have to map this entire thing somehow. But eventually I want to be able to do something like this, right? I take a value, I multiply it by the sign, and there we go, it magically became that. So essentially for the sign effectively, I need to take the value, take the range from 0 to 1 and map it to the range of -1 to 1. Right. So the way we usually map these normalized ranges to the specific ranges is that we take the actual length of this range, right? And the actual length of this range is like the right one minus the left one. So it's going to be 1 minus -1, right? So, and that way you have essentially 2, right? It becomes 2. and then you take this 2 and multiply it by this thing, by 0 or 1, right? You multiply it by 0 or 1, and then you shift it back by adding -1, so doing -1. So, and essentially, to generate a random sign, -1 or 1, we have to take this range, we're taking this range, we're multiplying it by 2, and we are subtracting 1, right? And effectively, if the rand, if this thing generated 0, 0, 2, -1 will become -1, right? And if generated 1, it will become 1. There we go. So basically we mapped 0, 1 into -1 and 1, right? Was it necessary to do like that? Probably not, but I wanted to do it anyway like this. So, all right, so we can try to play this thing now, but I'm afraid it's gonna be very, very fucking loud. So let me confirm that we are generating the right data, right? So let me just print out this stuff. So I'm gonna take value multiplied by sign, right? I'm not gonna try to play it. All right, so we have stream, so this is a white noise. So this one has to be as int 16. I have to explicitly cast it, I feel like. And this one has to be a callback. There we go. So, okay, so we're generating data that looks like a correct random data between like minus of 16-bit value to plus 16-bit value. I hope this is how it works. And I hope I'm not generating too much. So let me actually see. So 2 to the power of 16. 2 to the power of 16 is going to be what? 65. Okay, this is actually perfect. And if you do something like 15, it's going to be like around 32. And I don't see anything that exceeds 32 anywhere. So everything seems to be all right, more or less. Okay, so one of the things we can do in here, actually we can shift them not by 15 but by something like 10, and that will make it not as loud, hopefully. So this is going to be the volume of that sound. So let's actually shift it by 15, by 10, and let's go ahead and try to play it. So I'm going to turn down the volume right now completely on your side, so I'm going to be only listening through my headphones, right? And hopefully the mic will pick up whatever is through the headphones. By the way, disclaimer, before you do anything like that at home, be super careful, and especially don't wear your headphones right away when you experiment with sound like that, because you can actually damage your hearing. Right, this is actually fucking dangerous, right? When you're working on software that generates sounds and stuff like that, because a simple mistake can actually, you know, damage your hearing. This is very, very dangerous. So that's why I'm not wearing my headphones right now, right? I turned down the volume for you guys, and I'm gonna try to play this entire thing and just hear how it sounds, right? So, and then we can try to adjust the other stuff. You can already kind of hear it. So it is generating a white noise. Okay, so it's a little bit loud, so I would not recommend listening for too long. So we can actually bring it to the max, right? So how would it sound if it was a maximum? And I'm not wearing the headphones, and your sound is turned completely down. Right, so that's how fucking dangerous it is. So yeah, I can even show you. This is the desktop sound on the OBS, right? So you're not supposed to hear that at all, but you can still hear that because the mic picks it up. And mic picks it up because it's super fucking loud. And if I wear these headphones and I just like start playing it, that will be actually really, really bad. So let's actually do something like this, maybe even like that. Okay, I'm gonna try to actually bring it up on your side. You can kind of hear it. Yeah. So let me make it at least 10. Too much. Okay. Could the actual headphones break from the very loud noises? I don't really know. I know nothing about hardware, so maybe. But I would imagine that maybe headphones have some sort of like a mechanism for like to prevent breaking them if there is like a very loud sound. I don't really know. I'm not an expert on the headphones. So let's actually make it like 9 or something. Yeah, I think it's a little bit better. So you can hear the white noise, right? What's interesting is that there is a lot of high frequencies in here. GF was, thank you so much for 6 months of Twitch Prime subscription. Thank you, and welcome to our epic C Club. We're programming in C. Which is like, so the sound it generates, it's not particularly great in my opinion. Right, whatever is played in the video that I provided is actually like sounds way more pleasant, if you know what I mean. So I'm gonna give you the link to this thing and we can just listen to that, and it just sounds way more pleasant than whatever we have. Yeah. So the question is, how do we achieve that? That's a good question. Right. So what I feel like is that there is a lot of like high frequencies in here. So how can we control the frequency of the noise? Right. How can we control the frequency of the noise? Because we don't really control anything. We can only control amplitude, but the frequency is just like, how? One way I can see that, right? So one way I can see that. Essentially, for each sample, we're just generating a random point, right? So this is just like something like this. So that's what we're doing to generate that noise. What if we're not going to do that? We're going to just generate a random point, and through several samples, we're going to move towards that point. Right, and once we reach that point, we're going to generate the next random point. And through several samples, we're going to move towards that random point. And that way, we sort of like spread the random noise, making it hopefully lower pitched. Again, I don't know anything about like white noise generation. Like I know nothing, I haven't read anything. And the reason why I'm doing that is because I want to kind of explore this thing by myself first. And then maybe I can read about that. So, and through that we may be able to sort of control the frequency, and maybe that way we can just generate the noise of different frequencies and just mix them together and control like you know, what frequency go there or something like that. So let's actually see. So let's go ahead and do that. So white noise, to actually be able to do whatever I just said, right, we'll need to maintain some sort of a state, right? We'll need to maintain the goal where we're moving in terms of a value and the current value, and maybe even direction and stuff like that. And over time, we're gonna modify this kind of thing. All right, so let me see. So we're gonna have some sort of a state. Right, we're gonna have some sort of a state. Again, so what we're going to have, I suppose it's going to be something like goal, right? So this is the goal, and we're going to have something like current, right? So do we need to have some sort of a direction? I'm not really sure about that, because you can calculate the direction based on current and the goal, right? And the question is like, we probably have to decide on the step, on the size of the step, like how much you have to step on each sample, right? How much you have to step on each sample. So Yeah, this one is interesting. So here we're gonna accept the generator, right? So this is gonna be the generator. We're gonna do something with it. I'm gonna turn it off just in case. And in white noise, we're gonna pass the pointer to the generator via the user data, right? So in here, we're gonna say that we're using the user data, but we're passing it as the first thing for the white noise, and that will cast it to the GEN, and we'll have an access to these two things. And also this callback will modify it accordingly. All right. So on top of that, I'll have to specify the user data, right? I'll have to specify the user data, and it's going to be pointed to GEN, and we can allocate that GEN somewhere on this stack, right? So, and initially both of these things are going to be 0, right? And I guess that's fine, right? So when they become close, right, when they become close or equal to each other, we'll have to generate the next point of some sort, right? So that way I'm gonna just say, like, just fill it with zeros and whatnot. Just fill it with zeros. So should I upload this thing on GitLab somewhere? I'm not sure actually, so maybe I'm gonna wait until we have something like proper, at least to some extent. Okay. So how are we gonna do all of that? So we also have to catch the moment when we overshoot the current thingy, if you know what I'm talking about, right? So essentially, you can kind of know the direction if you take the goal and subtract the current. So here is your direction, right? That's the direction. Right, and let's imagine that you're gonna have a specific step, right? So we're gonna have a specific step, let's call it GEN step, right? And this is how much you step on each sample. And let's say that you're gonna step like 100 of the value, right? So this is a GEN step. What that means, you kind of have to normalize this value, right? You have to kind of normalize it. And to normalize it, you have to divide it by its absolute value, right? That way you get either -1 or 1, right? That's what you have, either -1 or 1. Or in case if they're equal, you get 0, right? So, and in that case, you're gonna have a division by 0, but I don't really want to think about it right now because it's not clear how to handle all this. So there's also probably like a sign function in C. Is there something like sign function in C? Sign function C. Is there a standard sign function, at least for integers? Because I don't quite remember if there's something like that. Thank you so much. That's an interesting way of computing that, by the way. So surprised no one has posted the type-safe C++ version yet. The type-safe C++ version. What's interesting in here is that if this thing is 0, right? If this thing is 0, it's gonna be actually 0, I suppose, right? So this will become false, right? And this will become false as well, right? In both of the cases, it's gonna be just 0. Okay, so that's actually a pretty clever solution. Maybe we can use that for C as well. But the question was, there is something from the standard library, right? The most readable way, okay. It doesn't really matter if you do it like that or like that. I think in a proper compiler these days, both of these things will be optimized to the same stuff. I feel like. I feel like they will be optimized to the same stuff. So we can actually test it out, right? If you have something like int sign int x, right, and so we can actually do something like sign 1, and here you have x greater than 0, minus x less than 0, right? Because it's kind of interesting. Is it going to be optimized to the same thing? Probably not. Or maybe it will be. Sign 2, and I'm going to just like take this stuff. Got bolt. So C and okay, so with no optimizations, obviously they're turned into different things, right? So, and if we turn up optimization to all three, are they going to be, they are the same thing, roughly, actually. Slightly different though. Huh. That's very interesting. Set G, C move LE. Huh. But in both of the cases, it got rid of the branching, right? So there's no branching in any of these cases, so that's kind of fine. So, all right. It's pretty cool. All right, so in any case, we need some sort of a sign function. Right, as16, as16. Though you can quite easily maybe just do some bit magic, right? Just do some bit magic, just take the last bit of the thing and just map it to -1 or 1. But it doesn't really matter in this case. I don't think so. All right, so here I can just take the sign of this entire stuff and multiply it by the gen step, right? So how much you have to step. So, and that thing is going to be the step, or maybe the direction of some sort. It's better to call it step. So this is going to be this step, and then what I'm doing, I'm taking again, and I'm taking the current, right? And I'm stepping it with that specific step. But the question is, is it going to overshoot, right? Is it going to overshoot? How do we know that it's going to overshoot? Because it can overshoot from different paths, right? So it can overshoot like positive and also negative. So I probably need to think about that. It would be better to actually go with floats, right, and interpolate with floats. But I really don't want to do floats right now, so I just want to keep it integer, right? So maybe we'll have to introduce floats, but I really don't want to. It's just like... Anyway, so let's make a small break, and after the break I'll try to see what we can do about all of that. So all right, so I had some time to actually search for my tablet, right, on the break. So I finally have a tablet. I'm super happy about that because I can finally like properly draw, and it's very important for me to be able to draw because otherwise I cannot you know, visualize things in my head properly for some reason. I don't know why. I think it would be better to go with floats. I think like have some sort of interpolation. Just a second, some sort of interpolation float A, which basically interpolates from goal to the current, rather from current to the goal, or maybe like previous and the next. So that way we'll be able to even precisely decide on the frequency on the white noise. I'm not really sure if it's like a proper frequency, right? So it's sort of like fake frequency because of how random it is. Maybe there is some other sub frequency or something like that. Like I don't really know, but yeah. So essentially what we'll be able to do is, knowing the frequency we're trying to achieve, we'll be able to like space out these different things, and because we know the time, the delta time of the sample, it will be super easy for us to interpolate, right? We just have to decide what is the time of A between 0 and 1. I'm not sure if that makes any sense, right? So yeah, essentially we have to decide on a time interval of moving from one value to another one, right? So we'll have to decide on that time interval and then use that time interval to interpolate with A, and that's how we're gonna move from A, like A to B, right? And since we know the sample rate, we know how much we have to step or something, right? So yeah. It's the root frequency. It's called root frequency. I don't know anything about terminology. Like I'm just trying to figure out how to do that. on my own. So, right. Let me try to do this kind of thing. So, and that way it will be actually super easy to, how to say that, to know when to generate the next value, if that makes any sense, right? Because once this interpolator gets to 1, you know that you have to switch to the next point, right? So that's how you know. And this is actually pretty cool. So this one is going to be something like current and next, right? And so you're moving from current to the next. And once A reaches 1, you basically assign next to the current and you generate the next. Right, so that's how we're going to do that. And we know that the delta time is going to be fixed, right? But to know that, we need to know our sample rate. So, and I'm thinking that maybe I'm going to like create a magical constant for this thing, for the frequency. Right, so this is going to be frequency 48000. So, and that way I can do something like, let me see. I can take 1 and divide it by the frequency, right? I'm dividing it by the frequency. And that way I know the delta time, like a sample delta time. Maybe we're going to call it sample delta time, but sample delta time is a huge word. I don't want to type it out. I'm going to call it sample dt, right? Sample delta time. So it's a 1 over frequency, and that's how much I have to add, maybe to the interpolator, maybe not, it depends. So it just depends on the actual time, right? On the actual timestamp that we decide in here. Right. So essentially, for the base frequency, so a single like period is essentially starting from here, then going up, down, and going back. So if we sort of like approximate all of that, I think it's like at least 5 points, right? Roughly, at least 5 points. So if you want to have a particular frequency, you take that value and divide like by 5, and here is your like time interval or something like that, if that makes any sense. Though you can actually have like 4 of them or something. It just depends what we mean by that. It's because of the randomness, it's kind of difficult to predict what's going to happen. But right, I think I'm going to specify that time interval maybe manually. I don't know. It's hard to tell. I don't know. It's hard to tell. But anyway. So in here, so this is the step. So this is the current, and what I do is I take gen next minus gen current, right? Then I multiply it by a, right, by this specific interpolator, and I convert it back into 16. Maybe it would make sense to actually floor it, just in case, just floor it. And then I convert it back into s int 16, right? And here is my value, so to speak, right? So here is my value, which I can assign in here. All right, so then I can take gen a and add is sort of like a gen step multiplied by sample dt, like so. And if at any point a became greater or equal than 1, I'll need to generate the next value, right? I'll need to generate the next value. Let me see how I can do that. So gen current becomes gen next. Gen next becomes this random value. And a, the interpolator, becomes 0, right? We reset the interpolator. So, and here we have a gen step. What's going to be the gen step? What's going to be the gen step? Usually, when you want to achieve a specific frequency, I don't know, my brain for some reason doesn't want to give me the answer what to put in there. I'll need to think. I'll need to think. So we can put like maybe something small in here. So initially, I don't know, man. So when you don't have anything, right? So that means, okay. So when we didn't have any sort of spreading for different frequencies, essentially the gain step was equal to 1, right? It was equal to 1, and to achieve, so gain step multiplied by sample dt must be equal to 1. So whatever we had before was effectively equal to 1. So to make it equal to 1, essentially, right, we have to take 1 and divide it by sample dt, right, sample dt. So that means we have this original thing. So and this could be our like sort of base gain step. So that way, we're not spreading anything, and we're basically getting the original white noise, the original static noise. And by decreasing this value, right, by decreasing this value, we can basically spread it out a little bit more. So I'll need to think like how we can control this entire stuff. Okay, so can we hear anything? I can't hear anything. That's very interesting. So let me think. So all of that is 0, right? All of that is 0, and that does not increase anything at all. So maybe these values are actually So let me see. Why is it not working? So it's something with this value. It doesn't seem to be equal to anything. Right, so let's actually print it out. Let me see. I'm gonna print it out, and maybe that will give us any information. It is 1. Okay, so that is 1. And once it gets to 1, it must generate something, right? It must generate something, but it generates nothing for whatever reason. Okay, let me take a look at what is generating here, right? So it's going to be stream I, show me all of your secrets, please. It's actually generating 0. Very interesting. Oh, I know what's happening. Okay, so it's being 0 at the beginning, then we add 1, right? We add 1. And then, since we reach the 1, it generates a new value, it resets it to 0. So because of that, it basically stays at 0 all the time. This is actually kind of dumb. Oh, I really like that. Okay, so one of the things we can do in here actually is just swap this around, right? So that way it will, yeah, now it generates, right? You just swap these two lines, places, and it's always 0. But in this case, it's like static noise. All right, that's actually pretty funny. I really like that. It's really sensitive to the order for some reason. It's kind of fun. All right, so how can we make this gain step smaller? Right? How can we make it smaller? By making this value bigger, we're actually making the whole thing bigger. By making it smaller, we make the whole thing smaller. Or maybe we can make this thing bigger. Right. So if I multiply this thing by 2, that means it moves like over a period of 2 samples, right? It takes 2 samples to move from one point to another one. That's basically what it means, right? So this value is how many samples it requires to move from current to next. I think that makes sense. Right, so now it will take 2 samples, and since this is a float, we can actually have like a fractional ones, right? So yeah, it's actually pretty interesting. So we have like a lot of control in here. So let's actually try to listen to this thing, and in theory, it should sound a little bit lower. So before I go there, actually, let me try to make it a little bit louder, so maybe you can hear it. I'm not sure if it's going to be too loud. So I have to be super careful. You cannot hear that, but you can hear something like this. Can you hear the noise? Can you hear the noise? I think you should be able to. Yes, is it too loud? Is it okay? Hopefully it is okay. All right, it's a hiss, right? Yeah, it is actually hiss, sort of like. Okay, let's actually try to spread it. Right, it took one sample to move from one value to another one. So basically it was as the original just field thing with the random values. Now let's take two samples. It will take two samples to move from one value to another one, and let's see how it changes the sound of the white noise. Did it change anything? I don't think it changed anything. So just a second, let me try to have like 3. I think it changes something. I think it sounds... That is very interesting. I really like that. Triangle waves, yeah. It's kind of generates triangle waves. We can also try to interpolate more smoothly between the samples that we take, between random samples. Maybe that will make the sound a little bit more interesting. But yeah, it does sound like a rain, right? It starts to sound more like a rain. Oh my god. So you can start to... I think this kind of weird thing is because of the triangle waves. Right. Yeah, the more we spread out the wave, the more pixelated it sounds, if that makes any sense. It does sound kind of pixelated because it is a triangle wave, essentially. So if we take like something like 20... Yeah, it is kind of pixelated because there's not enough resolution or something. So one of the things we can try to do is just like try to smooth it out. Yeah. So yeah, that's kind of cool. So, and you know what I want to be able to do? I want to be able to control this kind of stuff. I want to be able to have some sort of a UI that allows me to like have a slider where I can just like slide it up and down and just control this entire thing and just experiment with this kind of stuff. And also, how can we smooth it out? That's it. Oh shit! You know how we can smooth it out? We have an interpolator. So we can just do like a quadratic interpolation of some sort, if that makes any sense, because A is from 0 to 1. But if you multiply it by itself, it's still going to be from 0 to 1, but it's going to be more of a, like a quadratic, but it's not going to be like a perfect in some sense. I think it's going to be more like a, if you have several points in here, right? So it's going to be like that, right? Or something like that, I don't know. But I don't think it's going to be like that. Right, it's going to be like really weird. So to make it a little bit better, depending on the direction, we'll have to use like a different interpolation, either like quadratic one or the square root one or something like that. We'll see. So let me give it a try. So nah, it's not that different, right? It's not that different. Okay. Do we have something? I kind of liked how it sounded on like 10, if that makes any sense. Well, no. It's probably because of this thing. Probably because of... What was that? Was it 6? I really liked it at... Yeah. Around here. Around here, cosine interpolation from 0 to 1. How is it going to go? I'm not really sure if it's gonna work really well, but we can just try to plug cosine into this thing and see if it's gonna like sound better, but I didn't think so. So I'll have to take something into account. Yeah, I don't know. Alright, so let me go ahead and think about the UI. So we have some sort of a base where we can start experimenting, but it's kind of difficult to experiment when you don't have any sort of like interactivity. All right, so let's quickly develop a super simple UI that will enable us with that. Right, specifically, I just want to have like a slider where I could slide around and modify this specific value. So let's go ahead and create a window. So one of the things we probably need to do, we need to initialize the video subsystem. So this is going to be video subsystem. And let me not start this entire thing. By the way, before I go ahead and do that, I think it would be nice to upload that to GitLab for everyone to play with, right? So, and come up with your own versions of like interpolation or generation or something like that. So I think it's worth doing. So let's git ignore wine. I'm realizing that wine was a perfect name for this white noise generator, right? Because it does sound kind of whiny, not gonna lie. So readme, we're gonna have something like quick start, all right? And for the quick start, you're gonna have console build.sh and then wine. So I think I'm also wanna put some sort of a disclaimer, warning. Be careful while experimenting with this code. Loud sound may damage your hearing. Right, something like that. I think it's quite important, right? So let's do git init. Let's initialize this entire thing. What the fuck is going on? And ready, set, go. We're gonna go to GitLab and I'm gonna create a separate repo for this entire thing. New project. So create a blank project. Okay, my awesome project. Cool. So this is gonna be wine. I'm gonna go to readme, white noise generator in C. So this is going to be public for everyone and initialized. Enable static application security testing. Analyze your source code for known security vulnerabilities. Nice. And it's absolutely free. Holy fucking shit. So that's pretty cool. Thank you so much. Okay. Now I want to clone that. I want to take this SSH and I'm going to add it to my repo. Remote origin. Put this thing in here. So this is the default one. And can I push that? Let's push that right into the repo. Right into the repo. So you can find the source code in here. And for everyone who's watching on YouTube, I'm going to put that in the description. I'm going to put that in the description. Encryption.md. There we go. Source code. Source code. There we go. Wine. So if you want to play with this kind of thing, or you have a better idea on how to do things, go ahead and do that. All right, so let's create a UI, shall we? Epic UI. SDL init video, right? So let's see if it's going to compile. Might as well actually test if it's going to work. Okay. Why it doesn't go away? I can't disable it for some reason. That was weird. So I have to be a little bit more careful this time. So let's actually not play it, because there is an easy way to disable this entire thing, like just never unpause it. Right, and you can quite easily just play this entire thing. It doesn't react to Control-C for whatever reason. That's really strange. It doesn't react to Control-C anymore. Huh. It used to react to that, but now it doesn't. Probably because of the video, like the only thing that changed is that I enabled the video subsystem. So if I disable that, let me try to do that one more time. Now it is reacting. That's really weird. I enabled the video subsystem and it stopped reacting to Control C, probably because it set up some sort of like a you know, handler for, you know, sig int, probably because of that. This is really, really weird. But okay. So let's create a window. I don't remember how to create a window. Let me take a look. Video SDL create window. Here it is. So let's create a window. So main.c. So what's going to be the title? Wine. So it is going to be located at 0, 0. Width and height is going to be 800 and 600. So might as well maybe create some sort of constants, because I'm going to be using them for layouting, but it doesn't really matter right now. So what's going to be the flags? So what about the flags? So the window, does it have to be resizable? Let's make it resizable, just in case. Yeah, let's make it resizable, why not? U int 32. Okay. So then I'm gonna have a window in here. Right. If window equal null, that means we couldn't create a window. So we'll have to complain about that. ST error could not create a window because of reasons that we're going to say in here. Get error. There we go. And I'm going to exit with non-zero exit code. The usual stuff. So now after we created the window, we have to create the renderer. So let me see. File is write protected. Doesn't matter. Create a renderer. Main.c. There we go. So to create a renderer, we have to provide the window. The index is the driver. As far as I know, we can just put -1 in here and it will use the default driver. And the flags, I don't quite remember what they are. So let me see. If I remember correctly, we have to say that it's hardware accelerated or something. You can find the renderer flags in here. Yeah, there we go. So we can say that you want to use hardware accelerated stuff like OpenGL or something, depending on the platform, right? So on Linux, it's usually OpenGL. On Windows, it's going to be Direct 3D. On macOS, it's going to be like Metal or whatnot, right? So that's basically what it means. It's going to use the platform hardware acceleration. So then this is renderer, right? And if renderer equal to null, that means it failed to create a renderer as well. Fprintf std error could not create a renderer as SDL get error. There we go, and I'm going to exit with non-zero exit code to indicate the error. Okay, so SDL window C forbids nested functions. Ah, I see, I forgot equals, of course. Okay, I think it created a window. Right, it doesn't draw anything on the window, it doesn't refresh the window, but it created the window. That's how easy it was. It's pretty cool. And I can't close the window because I don't handle SDL quit. And I cannot even kill this entire thing because it catches the sig int, so I cannot control C my entire application. So, very cool. Okay, so if I try to kill this, okay, so at least it killed the whole application. That's very cool. So to make it quit, we have to handle the events, right? So we have to handle the events. SDL event while SDL poll event. At least I think this is how I pronounce it, right? So I keep saying the Slavic V instead of like the proper English V. Event. All right. And here we're gonna say switch event type, right? Event. Slavic V is much better. I do agree with you, my comrade. Slavic V is the best V. SDL quit, and then here we're gonna say quit true. All right. So I think that's it. So that way we'll be able to actually like quit at least, right? Right, I can quit it now. Oh, wait a second. Will I be able to control C this thing now? I am able to control C it. Okay, so essentially I think SDL, the video subsystem of SDL, sets up the handler for seekInt, and in case of a seekInt, it sends SDL quit so you can handle it. That makes a lot of sense. Okay, that's actually pretty cool. So whether you're trying to close the window or control C, it's all interpreted as SDL quit. That's actually pretty cool. I never thought about it. Okay, so that's SDL quit for you. All right, so I think now we need to draw some sort of a background color. So I don't know how to do that. Let me take a look at the render. SDL set color render color. I don't remember really. Clear. SDL clear. So one way we can do that, we can grab SDL like this and then clear or something like that, because I do kind of remember clear Q clear. Okay, SDL clear window. I really forgot how to do that. Render clear. Why couldn't I see render clear? Well, because I specifically grabbed for it. Where was that? Okay, that's really strange. Yeah. So I said, give me that. Oh, maybe because it's not a regular expression, right? So that's what you wanted. Right. There we go. So it was not a proper regular expression. That makes sense. Okay, so render target with the drawing color. Okay, so that's what I wanted in here. That's precisely what I wanted. I'm gonna provide the render, but it's gonna clear it with the current drawing color, right? So, and how do you set the current drawing color? So let me try to do that. SDL draw color, something like that. Set render draw color. There we go. So that's what I wanted. Set render draw color. So here's the thing about SDL. I never remember in which order these words go in these functions. Is it set draw render color, or is it set color render draw render draw color render whatever? I have no idea. So because of that, I have to use the regular expressions because I still cannot figure out the naming system of this library. So I just like, I don't know, like, is it render draw color? What? Just use a regular expression and just find the function. Anyway, so I think I'm just dumb. I think I'm just straight up dumb. But anyway, so we're gonna use the red color because it's a color of communism, right? So it's gonna be like this, and I think that is basically it. I set the render draw color, right? Then it's clear everything. And I think after that, you have to present the entire thing, right? So we're going to do present. There we go. Render present. Okay, so that's cool. Okay, so let's try to build everything, and there we go. We have a window, the red window. That's actually pretty pogue, I think. Okay, so let me maybe, I don't know. So maybe make it like a grayish color. Let's make it a grayish color. So this is like almost like a color of the background of my editor. Almost, not really, but pretty close. Oh my god, Just Kimi sent 100 bits. Thank you so much for 100 bits. Thank you, thank you, thank you. No question was asked, but I mean, no question is needed. I appreciate any help and any support. Thank you, thank you, thank you, thank you. So now we have the window, right? And we want to be able to control some stuff in here, specifically this parameter within the gen step, right? This parameter within the gen step. And what is it going to be? What's this parameter is going to be called? That's the question. So essentially this is how much time it takes to move from current to next, right? So it's more of like a step time. It's more of like a step time, and of course it has to be a runtime parameter of the GIN, right? So this one is going to be more like GIN step time, right? So, but we don't really have to prefix it with GIN because we're inside of GIN anyway, right? So this is a step time, and so that means we have to generate the GIN step based on that step time, right? So that's what we have to do in here. I'm going to turn this thing into a runtime parameter. So it's going to be equal to 1/6 sample dt. So we'll have to take this GIN step time, right? Step time, there we go. So, and then sample dt. So this is again step. And we're going to customize this parameter through some sort of a UI, right? Through some sort of a UI. So, and before we go in here, I'll have to set the step time to 6, right? So I'm setting it to 6. Alrighty, so can I just now compile this entire thing? And it seems to be compiling, so yeah. And as you know, if it compiles, it works. So, X-Way New Bruce X says, I'm new on this world of programming, I'm learning Python. Good luck with your programming endeavors. Python is a pretty good first language, I would say. So, it's quite important for the Python to be not the only language, I think. It depends actually. So if you're not really interested to go too deep into programming, so maybe Python is the language that you're going to use for your entire life. That's okay. That's totally fine. That is totally fine. So, all right. So how are we going to do all of this thing? We need to establish what's going to be the maximum and minimum for this value. So this is the time, right? And I suppose, oh boy, it's not even the time. The actual time is this multiplied by sample dt. So it's a time in samples. Oh yeah, that's interesting. It's a time in samples. It's kind of funny. Time samples. So if it becomes 0, we're gonna have a division by 0. So we can try to, yeah, it doesn't make any sense to make this value smaller than the sample dt. So the minimum value is gonna be the sample dt, and the maximum we can try to see what's gonna be the maximum, right? So let me enable the audio and let's just hear what we're gonna have in here. Okay, so if we make this value like 30, it's gonna be pretty horrible. It's gonna become more and more creepy the bigger this value, right? So what about like 100? Oh shit. That is so cool. I really like this sound. I really fucking like it. It's actually super cool. Holy shit. What about 120? Yeah, sounds more like a video game explosion. This is because it like has a very low resolution, right? So if we try to smooth between these samples, I think it would be a little bit better. So I'm just trying to establish the maximum value that makes sense. I think like after like 200 and more doesn't make any sense anymore. So maybe we can actually say that this is going to be the maximum. So step time, so let's actually do something like this. Step time minimum is going to be 1, right? A step time maximum is going to be 200, right? So, and we're going to be able to actually slide between these two things. Right. The question is now, how can we render this entire thing? Well, we'll have to decide what's going to be, like, where are we going to draw the slider, right? Where the slider starts. So let me see. So step time slider x, right? So it's going to be step slider x. Let's actually say it's going to be 100, and y is also going to be 100. So this is basically a step slider, step time slider. And another important parameter in here is going to be its length, right? Step time slider length, and how long is it going to be? So let's actually set it to like 200, right? So something like this. Something like this. And I need to sip my water. I need to sip my water. Okay. So essentially, we need to take the current step time value and map it from 1 to 100 to 0, 1. So then we can figure out the position of the slider itself, right? We can figure out the position of the slider itself. But before that, maybe we can just draw, right? So let's just draw a rectangle, right? So let's go ahead and do that. How do you draw rectangles in SDL? I don't quite remember. So fill, I think it's a fill rect. Yeah, there we go. Render fill rect. There we go. There we go. We just fill rect. So this is going to be the renderer. So this is the renderer, and we have to provide the rectangle. And what's going to be the rectangle that we're going to be providing? So here's the rect. The position of the rectangle, right? So x is going to be equal to the slider step time slider x. So this is the x, and step time slider y. This is where this entire thing is going to start. So then width is going to be the length of the slider, right? So this is going to be the length of the slider. So this is the length, and height, right? Height is going to be the thickness of that slider, right? So this is going to be the parameter that we haven't defined yet. So it's going to be step time slider thickness, right? Maybe thick, right? Something like this. What's interesting is that we may want to take half of the thickness, right? Half of the thickness, and subtract it from height, if that makes any sense, right? Because that will sort of center it at where it has to be placed. I think that's a good thing to do. Right, so this is going to be our rectangle. So if I try to compile it right now, it will complain that there is no such thing as the step time is slider thick. So let's quickly define this entire thing, and I think it's going to be like around like 5. All right, so do we see anything? We don't see anything because we don't have any caller, right? So we need to specify the caller. So set render draw caller. So let's, you know, it would be way better to specify the caller in like in a hex code, right? And for the hex code, I use my usual trick where I define a macro that accepts the hex code of the caller and splits it into 4 parameters in here. So people who watch me long enough, they know that trick. I use it all the time. But essentially in C, I define a simple macro, right? So it's called hex caller or whatever, right? And here I just, you know, take the code. So, and essentially you would be able to specify the caller like so. So you would be able to do something like FF, 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 FF. So let me make sure to do it like this. So it's going to be 8, right? So this one is going to be red, green, blue, and alpha. So maybe it would be nice to actually do something like this: green, blue, and alpha. So the thing you have to do in here now is quite simple. You take the code and you shift it by 3 bytes to the right, getting R, and then you, oh my god, then you simply extract that R like so, FF. So, and then you separate by the comma. So then for the green, you take the second one, first one, and the zeroth one, and there we go. You have a macro that makes it super easy to do things like so. Hex color, 0x, let's say 18, 18, 18 FF, and essentially what it does, it takes this number and spreads it across 4 arguments in here, right? It spreads it across 4 arguments. Spreads it across. Holy shit! I don't know how to speak. I'm sorry. Right, in that way you can just specify things quite conveniently. All right, so let's actually use the red color in here. And let's recompile this entire stuff. So this thing does not exist, and there we go. So I have a red, you know, line in here. So, and I can quite easily change the color of this line. So if I want it to be sort of like green, I just do it like that. And as you can see, I can just use the hex colors with SDL, with this specific macro, which is rather convenient, right? Which in fact rather convenient. So yesu kawaii freaking desu. So I want to make this thing a little bit longer. So let me actually bring this stuff somewhere here, so I don't have to like go up very often. So I think the length has to be like around maybe 500. I think 500 is actually good enough, right? It is in fact good enough. By the way, that way I can also specify something like step time slider caller, right? And I can put this thing into here, and then just something like this. There we go. Yeah, and it works. So interestingly enough, now I can have something like a background color, ground color, right? And I can just put it in here. Define background color 18 FF. There we go. Everything is pretty customizable, I would say. Everything is pretty customizable. So this is like a first rectangle, right? So this is more of like a slider itself, right? So I would even put this entire thing under the same group, right? So how do you call the slider body, right? I don't even know, the main thing, right? The slider body. Let's call it slider body. Slider body, because that's what it is. The next thing we need to do, we need to have the slider like knob. People say slide and grip, I guess, but I kind of like the knob, but maybe grip is also a pretty good name for that stuff. So all right, let's define something like step time slider, maybe step time grip, step time grip size, right? And we're gonna make it just rectangular, right? And the size is gonna be just half of a side. It's more of like a radius, if that makes any sense. So let's make it around. So if the thickness is 5, I want this thing to be bigger than thickness, so let's actually make it like 10. And in here, we're gonna have the grip, if that's how we call it. I'm not sure if that's how we call it. So it would be also make sense to specify the color, and the color is gonna be more like a red one, right? So that way, I'm gonna copy paste this entire stuff. So the color is grip color. So the position of this thing, let's keep it as X, right? Let's keep it as X. And in terms of Y, let's keep it like that. Yeah, that's fine. So width and height is going to be essentially grip size, right? So this is going to be grip size multiplied by 2. And this is also going to be grip size multiplied by 2. All right. So, but in terms of X, I think we want to sort of center this entire thing, and I'm going to simply subtract a single grip size in here. All right, so that gives me the right thing. There we go. So here we have this grip that we can move around. So if we kind of like swap them, if we can try to swap them, we'll see where exactly the grip sort of like stays. Right, slider X, God damn it. Let's actually keep all of these parameters in a single place, right? So they're all available in there. Yeah, there we go. So as you can see, like it's here, like at the center in here. Right. So what we're gonna do next? Next, I want to take the actual value of step time and map it to the position of the grip, right? So how can we do that? That's a very good question. So I can take the maximum and the minimum value, right? So min and max. Min and max. I forgot already. I forgot the name of this entire thing. And then min. So this is the value, and I can take the actual again step time and divide it by that. And here I have interpolator, right? Here I have interpolator, which I can finally map to the length of the slider, right? I'm mapping it to the length of the slider. And this is how much I have to add to the X, right? So let's call it something like grip offset, right? Or maybe like a grip value. I think that's actually a pretty good one. And this is where we add it. So this is a grip value. So if we set it to something like 150, right? We're setting it to 150. And here this one is another pointer. As you can see, it stays around 150, right? If we set it to, let's say, I don't know, 50, right? If we set it to 50, it stays around 50. So as you can see, its position depends on the actual value, right? But we can't control that thing yet. We can't control it. So the next thing we need to do, we need to somehow learn how to control it. So that's actually pretty cool. It's actually pretty cool. But I want to still swap them around. I still kind of want to swap them around because I think it looks a little bit better. So the question is how we're going to control that. Controlling that should be relatively easy, because the only thing we need to do, we need to detect that you actually clicked on the grip, right? And we know it's sort of like a hitbox. And while you're holding, we can take the X position of the mouse and map this X position to the step time, right? We convert the mouse position into the step time, and then during the rendering, step time turns into position on the screen. That makes sense? So, and that way we'll be able to sort of control the entire thing, right? So I think that's pretty cool, right? So let me see. So once we have this sort of slider, we'll be able to maybe abstract it away into its own like component, a reusable component that we can reuse for other parameters like volume and something else. Who knows? I think it's rather interesting actually. So that's pretty cool. Yeah. So I kind of want to make a small break because I ran out of water. So let's go ahead and do that. Let's make a small break. Okay, so now we need to handle the mouse position, right? If I remember correctly, it's SDL mouse, mouse motion. I think that's what we need to handle in here. Maybe mouse button down, rather mouse button down or something like that. So this is going to be the break, and this is also going to be the break, right? So mouse button down. In here, what we need to do is to So I want to make it in a form of like immediate UI. And for the immediate UI, I just need to keep track of the current state of the mouse. And maybe also current state of the buttons. So the easiest thing to do right now, in terms of like checking stuff, will be after we constructed the rectangle and rendered it, use this specific rectangle to see if you are within that rectangle, if that makes any sense. So the easiest thing to do, we need an indication that we're currently dragging the grip, right? We need some sort of an indication. Let's actually create a Boolean variable for that, right? So dragging grip, right? And initially it's false. And we only go into that state if we clicked on the grip and we're holding it right now. So that's how you know, right? So because of that, you have to do mouse button down. So for now, I'm gonna just do it like that. Okay. For now, we're just gonna do it like that. Mouse button down. And like I need to duplicate this entire thing. I need to duplicate the rectangle, the hitbox of this button, right? Hitbox of this button. So is there any way for me to detect that we clicked on this thing in here without actually handling any events, right? Is there any way to do that for me? It's actually a very interesting question. So I need to take the mouse position and the mouse button. SDL mouse position, I think that's how it's called, right? So get mouse state. You can get the mouse state, right? And here you get the X and Y, and it also returns the buttons, and you can check what buttons are pressed and so on and so forth. Okay, that's cool. So, and depending on the state, if you are not in a grip state and the button is down and you are within that value, that means you go into the grip state. Okay. So let me quickly do that. So it's int, right? Int xy buttons. SDL get mouse state. Get mouse state X and Y. Right, and here comes this stuff. If dragging grip, if we're not dragging grip and X and Y within this specific rectangle, right? And I wonder if there is any function that can take X and Y and just check if they're within this thing. Something like rect contains point, where I could just provide the rectangle and X and Y. All right, and this thing, so the mouse is within this rectangle, and the left button is up. That's something like, and buttons. SDL button L mask. SDL button L mask not equal 0, right? That means we're going into dragging grip state, right? It becomes true. So otherwise, if we are in a dragging grip state, right, and the buttons, right, the buttons are equal to 0, right, the buttons are equal to 0, we are instantly setting it to false. Instantly setting it to false. Otherwise, this is where we need to take the x and y position, and not really x and y position, rather x position, and map it to the actual again step value. That's what we have to do. So we know that this value, the x value, have to be between, I would say this thing, right? So this is the minimum value. So this is the minimum value, and the maximum value is the slider length, right? So this is going to be the maximum value. So plus slider length. We need to clamp x between these values, right? So I can even do something like float. So they are floats, right? I think they are. All right. Grip minimum, right? Grip minimum, and this one is a grip maximum. Grip maximum. And we need to somehow clamp this kind of stuff, right? How can we clamp it? Because we don't have a clamp function or whatnot. Also, we probably have to do it as integer, right? Even though they're floats, we'll have to cast them to integers anyway. All right. If x is smaller than grip minimum, we're gonna assign this thing to grip minimum. If x is bigger than grip maximum, we're gonna assign it to grip maximum. This is how you clamp values in C, where you don't have a generic function clamp, right? So good old-fashioned clamp, where you just have two conditions. I mean, come on. Always worked since 1970. Since 1970. Okay, so here's the value, and then essentially I can take that value, right? I can take that value and I probably can subtract it from the minimum, right? I'm gonna subtract it from the minimum, and that will give me the value from 0 to the maximum, right? And the maximum in my case is going to be something like this. And I can quite easily to just do that. Oh man, this is very interesting because I want to keep it in float. I do want to keep it in float. That's kind of interesting, right? So let's keep it in float, and I want x to be in float as well, right? So let's actually call it xf, right? So all of that has to be like xf, because then I'm going to use it to compute the float value, right? So this is going to be like this, and there we go. So here's going to be the value from 0 to 1, which I want to map back to like 1 to 200, right? So I need to like have a lerp for this kind of thing. I probably need to implement lerp to actually simplify all of this code, but I'm too lazy to implement lerp. Right, because that way I could just say like lerp f, and this is going to be this thing, and I'm just going to do from what is that, step time min, right, step time minimum and step time maximum. But I'm too freaking lazy to do that for whatever reason. I'm very sorry. It's just like, I don't know why I'm so lazy to do that. I just want to do that manually. Okay, so here's that, then I multiply this by that, and then I can just add the minimum here. And here is the actual value that I want to assign in here. Right, okay, so this is going to be from 0 to maximum, then I divide it by the length, which will give me 0, 1, then I multiply it by the range of the available values at step time, and then I bring it back to here. So this is how I map it. And essentially what I want to do, I want to assign the step time, oh my god, Emacs, to here. That way I'm sort of like doing this entire thing, right? Hopefully. So I'm gonna actually pause this sound just in case it goes wild. And also I'm going to be printing the values that were changed in here. Right, so always be careful when you're experimenting with the sound generation, right? Especially if you're wearing headphones and stuff like that. Okay, buttons SDL, get buttons as undeclared, so it has to be uint32. Alright, so rect contains point. Okay, SDL, check if rect contains point. Do I have to implement that myself? Point and rect, okay, that's cool. I have to really? This is such a lame function. Why do I have to wrap it in a point? This is the lamest function I've ever seen in my entire life. Like, both of them has to be passed by a value. Right, so this is so lame. Holy shit. Okay, well, maybe SDL point cursor. It's gonna be X and Y, I presume. SDL point in rect. Here's my rect. Here's my cursor. There we go. You're gonna be happy now because I don't really want to implement my own function. So here comes the other thing. So again, this is something like this. And this is something like this. There we go. Okay, so can I do... Okay, so I'm clicking around, nothing happens. And now I can slide around. As you can see, it is sliding around. But it's kind of offset, right? This is because I'm not setting the value properly. Right, so... yeah, it's pretty cool. And it is within the value that we set up, as you can see. So we already kind of developed like a very small immediate UI framework within our thingy that allows us to change this kind of stuff. Which is pretty POG, not gonna lie. Which is very POG. So something is wrong with access and whatnot. I suppose one of the things we want to do in here is maybe, I don't know, subtract X, or do we have to add X? Oh yeah, so we have to subtract it. Okay, so now it is fine. Now it is centered properly. Now it is centered properly. Okay, so let's go ahead and now unpause the stuff we're doing, right? Pause. So let me see. Okay, so that's pretty cool. I'm gonna make it a little bit lower for you. And now we should be able to control the parameter of the white noise. So yeah, we can now control this kind of stuff. So the next thing we could do is abstract away the slider into its own component, like in immediate UI style, and have another slider, for example, for volume, right? So, and maybe we could come up with more interesting parameters and also have a slider for customizing that. But I think we're gonna do that next time, if we're gonna do that at all. I'm doing this thing for myself, right? So I'm probably gonna finish this off screen. And I wanna already finish the stream because I'm streaming for more than 2 hours, and it's kind of difficult for me to stream more than 2 hours because it's kind of like intensive experience, if you know what I'm talking about. So I'm gonna push the entire thing into the repo for anyone to play with. Implement a slider that controls the how we call it, creepiness of this sound. Right, I'm gonna push that right into the repo. If you're watching this stream on YouTube, you can find the source code of this thing in the description. If you're watching live, you can find it in the chat. I'm gonna copy paste the source code in the chat, so it is available for everyone right here, right now. So if you want to play with this kind of thing, you want to do your own stuff, check it out. Does anyone have any questions about what we've done so far? Does anyone have any questions? I want to listen to how it sounds like in the headphones. So let me. So, Holy shit, this is so cool. I really like that. My god. Does anyone have any questions about what we've done right now? So we made a pretty simple white noise generator, which is kind of crappy, right? But it has like a simple UI and you can control some parameters in it, and it's just like, I guess it's something. You can take it somewhere, so it's sort of like a starting point. From here you can add more different interesting stuff. Alright, so there's no questions. I guess that's it for today. Thanks everyone who's watching right now. I really appreciate that. Have a good one, and I see you all on the next stream. I don't know when it's gonna be next stream. We'll see. The winner gets tea. G, what's up? Hi. So let's maybe rate somebody. I don't know. Is anyone streaming anything epic on this? It's not the science and technology section anymore. On the software development and game development section. Come on, Twitch. I believe in you. Pajlada is streaming. We are raiding Pajlada. We're straight up raiding Pajlada. So Twitch website gets slower and slower. Yeah, truly such. Sometimes it feels like maybe my computer is getting slower, but then I go to other websites and they're not getting slower. If you know what I'm talking about, right? So none of the other websites I use daily get slower, only Twitch. So it's not my laptop. It's definitely not my laptop. Pajlada. Alright, get ready for the raid, boys and girls. Get ready for the raid, and I see you all next time. Love you all.